the call. So you forget
Buttons, how do they work?
Here we go. All right. Broadcast is now live. People should be able to join. So you said that you can add this method getSQL column schema, but you cannot add it to existing .NET Framework versions. Therefore, we are back at the portability issue that Imo was talking about.
So we have something called facades, where we can put in the implementation of the delta. By delta, I mean something new in .NET Core, which can get data from .NET Framework. So how we are going to, okay, so talking about SQL client and digressing a little bit from the API, how we are going to do this is in the facade, we can always access the get schema table using the data table and transform that data structure into a read-only collection of DB column when we write that facade, which is going to be a bridge between .NET Core and the framework.
You're saying in the facade you will access.
It's a partial facade, I think. You can add new types to .NET Framework, and they'll put it in the.
I understand, but partial facades are on type by type
Looks like they're going to put it in the
boundaries. And this method getSQL column schema is on an existing type.
No, but
No, it's not.
No, this is new type.
no,
DB data, we do extensions.
It's an extension
So-
method, I guess, right? That they do.
reader.getSQL column schema is okay. So I've not documented it here. The getSQL column schema will be an internal function that we'll expose in .NET Core, which will not be accessible outside, but it will be accessible to our implementation of the schema generator or to anyone's implementation of schema generators.
But to be clear, like that function or that method lives physically on DB data reader. Is that what you're saying?
No, the getSQL column schema that lives on SQL data reader.
Sorry, SQL data reader, but that,
schema generator, right? So this is the new type. This is a new class that never existed before. So we introduced a new class called DB schema generator.
so there's a new type called DB schema generator,
Yes.
and then there's a new type SQL schema generator.
Yeah.
And in the implementation of that type, you will access a method that you expect to find
Only in the desktop.
on SQL data reader. Like that, but the question is, does getSQL column schema today already exist for Fairway?
No.
But then you can access that because that would require touching implementation.
Okay, Imo, I think this method is an extension. Look below. It's an extension method.
So
So it's not an instance method on the reader. But
I
then what is the implementation of the extension method? Because you have to return dot.
First off, the getSQL column schema
Yep.
is something we're going to introduce in .NET Core on SQL data reader, which will be internal. So, but when this class, and then we'll implement this class in the facade, which will actually get reader.getSchemaTable from the from the SQL data reader. So this class will have two different implementation, one for .NET Core
That's what I
and
meant.
the other one in the partial facade, which allows compatibility with .NET Framework on desktop.
That makes sense.
And the framework implementation will just access all the APIs that exist on the
Yes, that is correct. Yeah. So essentially, the DB schema generator is what we will allow every provider to use and to provide their own implementation. Now, so the next question is, Nick or anyone on the call, any questions so far?
No, I'm very curious about how the last class is going to work.
Sorry, which last class?
Keep going. We'll get to it.
Okay. So the question is, how do we access this, and how do we provide a schema generator? How does it become usable? And we decided that we can provide extension which will take the data reader, which will be on the DB data reader, and the get column schema will be exposed from there. Now this is a static implementation, which means that our implementation will need to know which instance of generator corresponds to which particular reader. And to allow that, we want to provide another extension where any provider can register their generator with the reader. So that is the register schema generator. And we say that reader.register schema generator SQL schema generator. And this is the job of the provider to register the generator that they have. And the calling APIs can simply call the reader.getColumnSchema, which returns the reader. Oh, sorry, which returns the read-only collection of DB column. The problem here is that ideally the register schema generator should be protected. I mean, so that the provider or the reader itself, or only the reader could have added a generator that it believes is the right generator for it. But with the extensions, we can't get to that approach. So, and now then we thought about, so all this implementation will be in the DB data reader extension. So to maintain the relationship between the object, which is DB data reader, and the delegate, we plan to use the conditional weak tables so as to prevent any memory problems, and so that the garbage collection happens even if we are tracking the objects which are associated with each other. So this is what we are proposing, and looking for thoughts or any improvements that you can suggest.
So if you didn't have the restriction of not being able to add APIs to .NET Framework as quickly as you want, how much differently you would design the APIs?
This will just go to the base class.
You will just add it.
You just put an interface or something on the base class for all of them.
No, right now we don't have interfaces, so it's a base class, which is for .NET Core we don't have.
No, I meant like if we could add a IDB schema generator thing that allows you to get this column schema to each of the
We don't even need the DB schema generator.
Okay.
At that point, you would just have get
A method with
column
the
schema, or gives you the collection, correct?
That's correct.
Yeah, it's just an abstract.
Yeah.
That's how the
Well-
rest of it's implemented already.
Well, we can't add an abstract method, right? So it would be a virtual that would throw if it wasn't implemented or something.
Yeah.
Sure. So would we still do something like this? Would you do this, and while we are transitioning framework APIs,
Sorry, if I
like, would we do both? This API
Mhm.
and add a method to new version of the framework to give you the columns directly from the reader, so people don't have to go through those hoops.
Well, one thing that I would like to consider there is that if I add something to the framework, then we have two ways of exposing the schema. One using GetSchemaTable, and then one using GetColumnSchema, and that would be confusing.
We already have that, right? Because people can still use this new library on the full framework and they have both mechanisms, right?
Yes, but only on .NET Core. So any library compiled against .NET Core will get the schema using the API that I'm proposing. But any API which is working right on top of the .NET framework, they'll use the GetSchemaTable. While forwarding calls from .NET Core to framework, yes, we will use the base API, the GetSchemaTable API, which already exists, to get the data from the framework. But on .NET Core, we have that data internally in the data reader, or we have that internally in the provider, and the provider will just populate this data structure.
So, like, besides the thing of like how the how we expose it, my other question is generally like more about the interactions themselves. Wouldn't it be easier for the user to literally just say, the user can instantiate, let's say, the SQL schema generator, pass in the SQL DB reader, and that's it? Because then you don't have to do this register stuff. And
Yeah,
then
but
you can imagine that all the generators would share a base type.
Are you
Where
talking about the consumer or the provider implementer?
the consumer, like similar to how the consumer usually it says,
Oh.
New SQL connection, new SQL command wires them together. They can also say new SQL generator passing in the reader, because then you don't have to do any registration. It just works, and then sure, like
No. So there's a big problem there, which is that for a library, any ADO library would have to reference every provider on Earth.
Right, it's the abstraction.
Yeah, that's the problem with that approach that we run into with all of these.
I see, because you want to be able to say, I don't know your provider, I just know that you have a DB reader, now I want to get the schema, right?
Exactly. Because right now, like, Dapper references no provider at all, even SQL, technically. The only reason SQL works is because it's in the full framework. If it were separate like every other provider, it wouldn't be there.
Right.
Yeah. I agree.
So I understand in a library you don't want to do the registration, but you would be okay. You are okay with apps basically having to do this registration.
I think it's very confusing, honestly.
It is confusing, but
The apps will need to know about any provider. Let's say they want to switch providers.
yeah.
Then they got to know what, let's say, SQL is providing. And
But I'm saying no matter what we do, apps have to do the registration.
This is the provider.
The provider itself can do this registration.
Right.
Who's gonna trigger the code to?
Yeah, can't this be done on a static method?
Sorry?
Like when you first use a reader from a provider, it can register.
You would have to do it per reader for a number of reasons, I believe. Simply because different schemes.
That could be I'm not liking the idea of the registration, but maybe if the provider in a static method from the reader, the provider itself could register that the first time they use the reader, so it would be available for the user.
Well, the bigger problem is that, I mean, like in the same way we can't add APIs, we cannot change the existing implementation of full framework, right? So that means, as Christoph said, somebody has to trigger that registration. And it cannot be anything that already ships in the framework because that would require us to change full framework. So the best we could do is give people a library where they have to basically call a method. I mean, that's the best.
So in the full framework, you don't need to call register because you can have the get data tables, the existing data tables. So you don't worry about this generator because you can directly get from the.
No, but it's about imagine the case where somebody wrote a library that is compiled against the surface area of .NET Core, and is using that library in the context of full framework. So how would that guy be able to get a handle on the schema generator in an abstract fashion? And the answer would be it wouldn't, right?
Yes, so that's what I was saying, that the register schema generator shouldn't be exposed outside the providers, and that's something that we are struggling to do, and that for which we don't have a solution right now. Ideally, coming back to Christoph's question, I want to say that typically a reader would register its own generator when it will be constructed. So that would be the ideal place, and because this is something which should happen naturally, you know.
So how does that even work? Because like one data reader could have multiple schemas, right? Has that been considered? So for example, if I do a multi-read of like select, then select, then select, then select to reduce my round trip times, that's actually 4 different schemas, and it depends when I call it.
Sorry, so if you have a data reader with multiple schemas, could you repeat your question, Nick?
So let's say I just have 4 select statements in a batch, like select with a semicolon, select with a semicolon, and SQL Server. That's 2 different schemas. And when I call GetSchemaTable, like which position I'm at in the reader, actually matters. So there's like a lot of levels of confusion that this introduces. The only way this works is a lot of internal exposure from your data reader to your column schema generator in between the two, and keeping that internal and hoping it doesn't like. This is going to be pretty hairy even at the provider level, right?
Well, so to answer the first question, what happens when multiple commands or multiple statements are executed? That needs to be taken care of when you're calling the API called get column schema. So at that particular point, whatever your reader should, or whatever data should be coming out of or out for schema, that should be returned at that time, and the generator or the reader, however they want to communicate with each other, will have that logic as in at that state what to return.
You're registering a func of DB schema generator.
Yes.
But I think what you want to register is not a func of that. I think what you want to register is a func given the data reader, it can produce the generator. Because in your case, you literally call the registration on the instance, which means you have to re-register it for every single instance. I don't think that's what you want. I think you want to say, I know how to deal with a SQL DB data reader, so I can say I register that for any SQL, right?
Yeah, so we considered that approach as well, and why we discarded it is we thought that, yeah, I mean, a generator can work for a particular type of reader.
Yep.
Right, and that's what should ideally happen. But what this allows is flexibility for generator to be stateful. I mean, ideally the generator should be stateless and it shouldn't have any data in it. But if I'm associating a generator with a type, then that particular generator stays for all instances of the readers.
That's correct.
So that that is something that we thought is not ideal in case someone wants to make generators stateful and use it for a particular reader as such.
Well, I would say, I mean, you have two options, right? I mean, it depends on what your state is, right? If you can derive your state from a reader, then you don't have to do anything because you get the reader passed in, right? If you need to create some cache or whatever, you can still do that, right? There's nothing stopping you from saying, I don't know, I cache some information, I use a conditional weak table or whatever, right? I mean, so you can still maintain state if you have to. I think the reverse is more problematic, which is now, let's say Stack Overflow, right? And I do these things like a million times. Do I want to have a million of those guys floating around in my memory, and then GDC has to collect all those instances?
So
that seems maybe excessive.
As I look at it, correct me if you think I'm wrong, but if you have those million instances floating around, so first of all, the idea of having a delegate there is so that we call the generator only when it is needed and it's not instantiated. And instead of having a generator type being passed into the register.
Well, but I mean, I don't know how that works, but I mean, I would assume you would have to assume somebody will call this thing, so I have to register upfront whether or not it's being used later down the chain, which means the func is definitely some object that you have to allocate. Like even if that thing itself doesn't do anything, you still register.
Oh, I see.
You still have to allocate the callback, right?
Yeah, I see what you're saying. Yeah. So
we would allocate about 500 million lambdas per day to give an order of scale there. I mean, it's quite a few, right?
Yeah, that's a few objects, I'd say. It's only paid if you see the big bucks.
One thing that maybe I'm not getting this right, but isn't the schema generator particular to a specific provider, so it can access the internals of the current state of the reader?
Mm-hmm. Correct.
So in that case, wouldn't it be only a single registration per provider in the same map domain? Like once you register, any reader can call that method, and it will access the current state because it's stateless. So it needs to access the reader and get that state directly at that moment. So there shouldn't be any overhead there.
So what you're saying is essentially register or associate the generator with the provider and let the func you register being basically get the reader being passed in essentially, right?
Yeah.
Yeah, that seems right.
Yeah, that would be an option.
So
can you go from the reader to the provider? Is that accessible?
Yeah, I don't know. Like how do I get the DB provider from a given reader?
How do you get the DB provider? You mean DB schema generator?
No, the existing provider model. Like how can I walk up from a given DB data reader? How do I know which provider that guy is from?
Based on the type. So when you call the get column schema, you will get specific generator, right? Based on the type of the DB.
No, I get that. What I'm saying is like
forget these APIs.
Forget these APIs. Like in today's ADO.NET world, right, there's providers and there's readers, right? How do I know?
Every provider has its own implementation of the reader.
Yeah.
Is there a DBReader.provider property?
Yeah.
Right.
You would probably put it in the static constructor of your reader, because the first time it's used, it'll register itself.
Yeah,
it'll really be kicked off by the connection and everything else, but it'll just run the first time, right?
Yeah. The problem I see there is that anyone can override your provider if it is added in a static way like that. And so let's say that, I don't know, if there is a problem somewhere and someone says that, okay, I'm going to register a new provider for SQL data reader type. And since it is linked to the type, it can potentially include a lot of bugs, right?
Well, I mean, I would know how to do that, but I mean, there's other examples that we have done the similar thing. I mean, I remember an API review of somebody from the Azure SQL guys, I believe, and they have a very similar pattern where you essentially register something with a type, and then basically once you have done that, the next time you call the registration, it will actually not allow you to do that. Like it's a one-time thing. So the first guy who called register or associate this type, this generator, the next time somebody calls the API, just say, well, you can't do that, you already registered something. I mean, which would probably work. But the other question is like, why would you even do that? Because I mean, at the end of the day, like it's the user's process. I mean, if you want to destroy that, that seems unfortunate, but it seems like the easiest way. Right?
It seemed like a race there to me. We did consider this for sure, and it's like, where do you register?
Yep.
If you do it in the static, so the way, if we had to go this route, I'm still back on let's add them to the API, but I would do a register schema generator of T, where T is of DB data reader, and then each type can register itself, right? You're not registering a data reader. You're saying a SQL data reader goes to this generator. A MySQL data reader goes to this generator, right? You're singleton of that. And then that's a dictionary or whatever behind the scene. And get column schema just switches on the type of the data reader very simply internally to this class, right? And then you only need to register it on the static creation because there's no race. That the static constructor takes care of all of it for you.
Yes. So the only problem with that approach is that it requires changing the implementation of SQL DB reader in the full framework, which is exactly the same complexity as adding a whole new API.
So why would it? Why wouldn't you just call in .NET Core static method that?
Well, in .NET Core it's fine, but what would be the behavior be if I reference that library and run it on full framework? Because I cannot actually have code in the static constructor of SQL DB reader to register that guy.
But in the full framework,
we don't need the registration.
We don't need registration because we can directly get it from get data tables, the whole.
Yeah, we don't care about.
Yeah, we don't.
No. If my library is compiled for .NET Core, I need it everywhere.
Sorry.
Right. If my library is compiled against .NET Standard, I need it everywhere. I can't just. I don't want to if-def for the old method for the next 20 years, right?
Well, I think what he's saying is something different, which I think is the same thing that I missed. It seems what you're saying is that, you know, this API here would be fully portable. But my question is still, how do I get from, like on .NET Framework, given the DB data reader, meaning given the base type, how do I get to a DB schema generator?
On .NET Framework, you don't.
No, I need to because I have existing code that is compiled against the common subset between .NET Core and .NET Framework.
They just, in the implementation, instantiate the generator. And they don't need to register because they can call the underlying abstract.
That would be fine. My question is still that, you know, I'm consuming code. I get passed in a DB data reader.
You get the DB data reader, and then when you call this extension, you directly call DB data reader get schema tables without any generator.
And you transform it into a read-only collection of DB column.
So this generator is fully purposed for .NET Core. For .NET frameworks, you don't care about this generator.
No, I think we're still talking past each other. So what I want to do is, I have a library. That library is, let's say, let's just come up with something stupid here, but for the sake of argument, let's say I'm Stack Overflow and I build a portable library that basically does my data management. I want to use that library both on .NET Core as well as full framework. So that library, all it gets passed in at some point is a DB data reader. How am I able to get its schema generator?
You don't get every schema, you get columns. Look, you call get column schema, and you get a read-only collection of columns.
So what you're saying is essentially the portable API isn't the generator, the portable API would be the output of that, which would be the schema information. The way you get to the schema information on .NET Core, it's via the generator, and on full framework, it's via a different mechanism that gives you the same.
Yes.
That may not be a bad
Well, actually, but then I'm thinking, given we're going to have different implementation for this get column schema method that returns the collection on framework and on .NET Core, why don't we add a virtual method to .NET Core to actually give you the collection? Don't have the generator. On .NET Framework, this method just calls the old APIs. On .NET Core, there's new set of virtual methods like a tester and a
or an interface.
New set of basically virtual APIs on DataReader directly. So then people don't have to go through the hoops of registration. They just implement some abstract APIs.
What I'm understanding is that make the changes in framework and then come back and do this here.
What is it?
So are you suggesting that first make the changes in framework and then come back and do this here?
No. On .NET Core, we will have basically virtual APIs to give you the columns. In .NET Framework, you already have existing APIs, and this extension method will just call either of those two, depending on which platform you are.
Well, I'm still not quite sure what you're saying, proposal. What you're saying is DB data reader on .NET Core, we had a virtual method that gets the schema. For Framework wouldn't have that virtual.
Exactly.
So that means you would essentially treat the ADO.NET surface area of .NET Core as essentially a later version of the same API and desktop.
Basically, new .NET standard.
Or you can do an interface.
Yeah, you
just define an interface that's basically going to have the message you want. So, and then the .NET Core implementations of DB Raiders will implement that interface. .NET Framework won't yet. We can eventually have them implemented later.
I still don't.
It's different. It's different generation, correct? It's different .NET standard. But
So
because then we end up like, you know, in 5-10 years, we now end up with nice APIs that don't have any registration. You just basically implement up, you know, override the virtuals.
If it is implemented, if we add a virtual in DB data reader of .NET Core, wouldn't that break the type for us?
Yeah, it's going to not be compatible with that framework. That's why I'm saying you add an
We would
interface.
have to have two different. We would have to have two contracts. We would have a newer
You don't need
version.
to have a new contract if you just make it an interface and not actually have it directly on DB Reader, but you can query for the interface on DB Reader for .NET Core, and you're good.
I don't know if it changes anything because we still have to have two different generations and like we have to
The
play.
interface can be.
With the interface, we can add.
Yeah, the interface is not going to be directly on DB Data Reader. It's just going to be a separate interface that's going to be exposed to get column schema method.
Who's going to implement this interface?
All the new DB Reader, the database readers in .NET Core will implement that thing.
Yes.
And then in Get Schema, you'll query for this interface. If it doesn't exist,
This breaks the other providers, right?
which providers?
I mean, so we have two assemblies. One is System Data Common, which offers a programming model for any database provider. So we have System Data Common, which is a data model, and System Data SQL Client, which is implemented on top of it for SQL Server. At the same time, we have folks working on other databases using the Data Common programming model. So the DB Data Reader is a class in System Data Common. But the implementations really lie in all these other providers who understand the databases they are working on. So
There's nothing wrong with adding this new interface into Data Common.
But what does the interface buy you? Because against the full interface, you're not going to have it. So effectively, you're generation 1.5 anyway, right?
No, you can add the interface, and then .NET Core will have it implemented. The interface will exist, but the providers or the readers or whatever won't implement it on the full framework. But then you still have this piece of code that is different, that's like the extension method or whatever, that's implemented differently on the full framework and on .NET Core. So on full framework, it would just say, call the old API and translate it into DB columns. And on .NET Core, it would say query for this interface and return its result.
But then what I'm saying is I don't understand why we need the interface, because we could, instead of doing the query on .NET Core, it has the new generation and just calls the virtual methods. Like,
Well, because we can do, with the interface, we don't need a new generation.
Yes,
We
that
don't need
exact API can be supported on .NET
in
Core.
which the contract will the new interface be?
Be on System Data Common. And that
Seems
interface
to me like a new generation then.
that doesn't need a new interface, new generation necessarily. That
It's
interface.
partially facade on desktop, right? So
Is it?
it's partially facade on desktop. It's a separate
Yes,
type,
the
right?
interface will be defined directly in the partial facade implementation for System Data Common.
Yeah, I was on the phone. I heard the conversation's direction, so I wanted to come in and.
I see. The
Yeah.
interface
So it
will be
doesn't
just.
require
I
anything.
see.
Everything else does kind of work across the board.
I see. Okay.
So I mean, I think the high-level goal that you had, which I think is good, which is to say, can we get to a point where the APIs don't size?
Exactly.
And I think that's generally, I think, what I would be advocating for as well. I think what I would do, though, is slightly different from what you propose. What I would try to do is I would try to create a world where you can today, where basically still target both without having a new generation. I think that's another thing we should strive for. What I would do is I would say, if you're running on full framework in version 4.6, the app is responsible for calling some method that calls the registration. On 4.7, that code becomes a no-op. It doesn't do anything because the framework providers already do it for you. So moving forward, that manual piece of code that the app has to do disappears. It doesn't change anything for the library authors because they assumed registration already happened.
There's no. We already. I think we reached a design where there's no
You don't need to
registration.
do a registration.
Well, I would say not entirely, because it depends on what you want to achieve, right? If you want to say the portable API is essentially the schema is being passed in, then yes, you don't need registration. If you want the going from a DB data reader to a set of schema information, if you want that to be portable, you require some piece of registration.
No, it's an extension method, and it has two implementations. The framework implementation just calls all the APIs. The .NET Core implementation queries for the interface and gives you the collection.
Yeah.
Otherwise, fails.
No registration required on either front.
I see.
How will the .NET, how will the .NET Core implementation query for the interface implemented by the provider? So, how will it know that in the static?
Cast.
Yes. Just cast. It is or has cast of the data provider, data reader just casts into it. If it casts to it, then you can call it. Otherwise,
okay. Oh, sorry.
But if it implements it, aren't you going to break the type forwarding again?
But what will I? Sorry.
It won't break type forwarding because the interface is a separate type. So that separate type, type forwarding happens on the granularity of the types themselves. So with an explicit implementation of this in .NET Core, it wouldn't appear in the contract. So it wouldn't show up in the reference assembly. So the type forwards that we would have, the type shape of the type implementing this in .NET Core would look identical. The type shape would look identical. It would be supported by the public surface area would be supported by both desktop and .NET Core. We would add a new interface. That interface would appear in the contract. And in .NET Core, it would be in the implementation DLL. And in desktop, we would have a partial facade where most of the types were forwarded to desktop, but then this new interface that we added out of bin would be in the facade. And so as a result, people calling could use the base type, try new as. They'd have the interface definition on desktop because it would be in the partial facade. They'd have it on .NET Core, it would be in the implementation. That as cast would fail for desktop. It would return null. And on .NET Core, with that .NET Core implementation, they'd be able to get it.
So you're saying on .NET Core it would be the base class implementing it, whereas it would be each provider on full CLR.
Yeah, on full CLR, we wouldn't even use the interface until later on. We would just use the old APIs to get at the schema data.
And even on .NET Core, the concrete subtypes would implement the interface, not the base type.
The concrete data reader.
Sorry, I missed out on that.
But do we need to add a contract for the new methods in the base cluster?
There won't be any changes to data reader. It'll basically be you'll data common. You'll add this new interface, and that's it. Yeah.
All right.
And you obviously still need this extension method for that, but that's a separate library.
Now the question is, like, do we think that's a good API? I mean, that would be.
So one of I would rather wait a generation, honestly, and have it done right than kind of hack around. Because if I want to inherit the SQL data provider and extend it, I'm now completely screwed, right? Because it's all internal. Like to communicate between the two, it's all internal details and kind of very hairy. I couldn't actually enhance a provider anymore.
Couldn't you? So with an interface, you can always cast your base to the interface and call those members. It's a little bit more work than just calling base dot, but you can, right? Is that the scenario, or do you want more API than would be exposed in the interface?
It's more API because if the communication between the two, the extension method is a bunch of internals to get the internal bits out of like the TDS stream to populate the schema columns to say, is this a varchar max or is it a 250 or whatever? That's all internal unless you want to expose it on DataReader via your type. I mean, either way, it's going to get pretty nasty.
I'm not sure I understand because the interface would just give you the collection of columns. So each concrete data provider would implement this method to give you the columns. You don't need to do any tricks with internals or anything.
Right, but they're implementing it where? On their DB data reader?
Yeah, the interface is implemented on the concrete.
By the provider, not on the DB data reader. Is that correct?
No, I would expect the interface to be implemented by the data reader, but
the base class?
Not the base class, the concrete ones.
The actual, the concrete implementation. So it's a SQL client's SQL data reader implements the interface.
Yeah. Which is the other unfortunate thing, because it means for desktop, like if we were to do a virtual on the DB data reader, all we would do is we would have the default implementation essentially call through the old system. So that means every provider that today supports getting schema information to data table will now magically support the new API with them doing zero work. If we require the concrete things to implement an interface, that means, well,
we can add the interface to some of the concrete ones in the base thing and do the same thing.
No. On .NET Framework, it will all work. This interface's code path will not even get executed. It will
just talking about the future version of the .NET Framework when we add this interface to the code.
Yeah. Well, you kind of have to, otherwise it makes no sense.
Well, so what we could do is query for the interface. If it fails, use the old APIs. If it succeeds, just give you the collection that the interface implementation returns.
This is what we're going to do in that extension method right now.
So on .NET, I think it will.
So any existing .NET Framework data readers will just work,
I suppose.
Not on core, right?
They will on core because we're going to provide this extension method as it implemented on top of core.
Well, I mean, on core, I mean, it's generally work, right? Like, existing providers will not magically work on core either way, right?
Well, only when you're running on full framework. Sorry, yes. You have to do work to convert it to run on core alone, yes.
Yeah, I mean, if you consume the full framework through the view of .NET Core, as Christoph said, well, the view is provided by us, so we can make always the existing system work. Personally, I mean, you're right. Like, I think from a do we have the right knobs in the system? Can we express what we want? It seems not bad. I just think that from an implementation standpoint, it's super weird to say, basically, if you look at the inheritance hierarchy, everything of the APIs is basically a bunch of virtuals or abstract that you have to implement. For schema information, or you have this other thing on the side where you basically have to know that you have to implement an interface in order to provide information. That's unfortunate.
But then I wonder whether we can, in subsequent versions and generations, we can actually implement this interface on the base type.
Make virtual.
Add a bunch of virtuals that
just one, really.
Basically implement the interface.
Just one method. We're talking about get schema columns, right?
It is potential we could add it directly onto the base classes in the future generation. Yes.
Well, when are we talking future generation here? Like, I know 4.6 is lining up with 1.4, unless it's been renamed to 1.0. I haven't looked this week. Sorry. I don't know. When are we talking that's the next generation's kind of thought towards at this point? Like 4.7 or 4.6.2 or?
I think generations can move as fast as we want. The problem is our ability to change framework. That's essentially the slow truck here. And I think that we published some ideas that we said we can imagine everything between 1 time a year to up to 4 times a year for full framework. I don't know how realistic any of those extremes are, but I mean, even if we, let's say we could ship the framework 4 times a year, the question is still for library authors and other people, like, what's the adoption rate of those guys? And that's more like our customers being able to install the full framework, which is a bit of outside our control.
Yeah, the reality of it is, like, I just assume 2 years after a new version of the framework gets out before it actually reaches saturation to a point that library developers could realistically consider only targeting that new version, because you have shared hosters that like, they won't pick it up. You have OSs where it won't be in the box. So for people to use your library, they end up having to take on a pretty heavy OS update as part of their redist, and that's a non-starter for most library developers. It might work fine for like the people building individual solutions, and they say, hey, I really need this new feature, and I want to get that new version of the framework to use it. But from like a portable, like, it doesn't really satisfy the like, if you have people who are asked, like library authors like Azure or other folks out there who want to depend on this new functionality in their library, then it's not realistic. It doesn't really achieve their business goals to tell them they need .NET 4.6.2 or .NET 4.7, because we're not yet to a place where that can just immediately go out there. It's not like NetCore.
So, like, do we even need the interface though? Like, I mean, let's say we would actually add the virtual in .NET Core in a higher version of the contract. Like the consumer side.
You wouldn't be able to write a library that can run on.
No, I mean, but the point is, you're not actually consuming the schema information through the interface either. The way the library author is consuming is about the extension methods, right? And the extension methods don't have to depend on the interface on the surface area. So that means the portable thing in data common that provides the extension method can today support full framework and .NET Core.
I think
the only thing that would be have a higher version of .NET Core is essentially the ADO.NET or like the DB reader thing that the providers would actually derive from.
Yeah, but then it means we create a new generation just so we can add new APIs to DB reader.
Well, I mean, there's always a future, I guess, generation that we have. So I mean, that would not be a problem. It just means if you target that, you lose support for full framework. But you can target the older version if you're a consumer. And then if you're a provider, then you target the latest.
So you'd have to remove the extension method, though, right? Or you're going to have an ambiguous file?
Well, it depends on how the extension method is being exposed in general. But I mean, the way C# works is if there's a conflict between an extension method and a member, we'll always prefer the member. So in that sense, it's not ambiguous. We'll never cause a compiler error, but it does cause confusion in MSDN and other places where these things show up side by side, which is why we try to avoid that. But
no, but we could, like, why would we not forever keep the extension method? And the interface member would be implemented explicitly in the extension method.
Well, I care less about that. I care more about the fact, can we get rid of the interface at all? Like, do we even need the interface as a secondary type?
So I think we all agree we can, but that would mean we need to create a new generation now for data.
But what I'm saying is there's already a future one. It would just be in the next bucket desktop implements. That's the thing you have.
The interface, or getting rid of it, eliminates boxing, which, like, we're actually concerned about performance at every level. So when we're, like, Dapper's written in IL for the most part when we're doing with this, right? So getting rid of the interface and have a direct member later is definitely preferred.
What? How boxing?
Yeah,
like, this is a reference type.
Your data reader is not a struct, is it?
No, not from the
Then there
base.
should be boxing involved. Then.
You're going to have it depends how you're using the DB columns getting off. But there are conditions depending on where your registers are as to you're going to allocate another ref, another type, and sometimes a box. I know it's not like struct, it's very rare, but there's cases in which you get backfill. I'm not really concerned with performance about this because this is a rare. Right now, look at what it does. It spins up a data table, which is a monster. Right? I actually went through this before this meeting. I went and ported data table to .NET Core. It's not fun. It took like 4 hours, and there's a lot of crap. And I'm kind of totally convinced we shouldn't do that, which is why I have not brought it up. Like I went through it because until you do it, that's stupid. But yeah, the interface long term is just weird. If I go to implement a data provider, I'm going to stick all this stuff, I'm going to implement everything, and then my users are going to be like, why doesn't this work? Oh, because this interface way over here is, it's just weird.
I think I'm not 100% convinced we would have to do some prototyping, but I'm pretty sure we can add the interface to the base in a future generation, and therefore in the future, all provider implementers will be kind of forced to implement it. It will not be like, oh, they forgot to implement it and now it doesn't work.
Yeah. So once we can get supported on the desktop, we'll be able to add it to the base.
But we can add it to the base in core now, right?
No, everywhere.
Yeah, but you're saying like we would add it to the core in .NET Core right now.
Yes.
Right, explicitly.
Yeah, we would bring it to the desktop framework in a later version, yes.
What do we do about two APIs offering the same thing? I mean,
the extension method versus the member is not a problem.
No, but the interface will expose this information via the data reader, correct? And what I'm saying is that when we take it back, the desktop, where we already have a method which says get schema table, and then we expose this, we have two APIs.
We can implement it explicitly. So on the full framework, you can implement this interface explicitly as well, so this kind of doesn't show up as two different things. You literally have to cast to the interface in order to actually see the member.
I mean, technically you're right, but we have this same issue in plenty of other places where we basically had, I mean, if you look at the general class of problem that we're trying to solve here is we have existing feature It takes a dependency on an API or technology we want to get rid of. So for layering reasons, we introduce an alternative.
Okay.
And now on the base, you see both, right? Reflection has the same problem in some cases.
Also, you're going to have this problem no matter what. Even this design introduces basically a new way of doing very similar things, right?
Yeah. So with this design, I mean, at least I had that, okay, this is not going to make it to the framework. And the facade will take care of mapping the data from framework till here. So I'm not saying that this is wrong or right. I'm just asking, like you said, that what have you done about it, or have there been any precedences?
I mean, we have done this in other places. I mean, sometimes what we do is, like, basically your proposal would have the nice side effect that if you do file a new .NET Framework app, you don't actually consume the full framework via the view of .NET Core, either via portable or via NuGet packages.
Mm-hmm.
You don't see these APIs, right? So as far as the .NET Framework developer goes, there's only one way of doing it, and it's the old way. The problem with that approach is that if we want to get to a world where, you know, we have more uniform APIs, you kind of even want the full framework developer to start using the new APIs, so that, like, after a while, like, you know, yes, the old way is still there on full framework, but if you switch between, let's say, your ASP.NET 4 app targeting full framework and your ASP.NET Core 1.0 app that targets .NET Core, you see the same APIs, and you're used to both, to using both. So I mean, there's an additional tax, but I think from my point of view, there's actually benefit of at least saying, yep, there's old stuff in framework, but the new stuff is always there as well, and that you should always use the new stuff because that's the thing that's common between. So in that sense.
But if it's a very big concern, I think implementing the interface explicitly,
Absolutely.
and then the extension method, if you don't, you know, reference the package that has the extension method, you don't see that.
Yeah, the only problem with that approach is it prevents us from doing the virtual thing, right, on DB DataReader. Like, in order to have a public API or protected API you can override, like, you cannot really do that. Right? You would have some sort of API that's public that introduces an alternative to the existing GetSchema column or GetSchema table, whatever it's called.
So let me see if I can just understand. The total what we're talking about is .NET Core, as it stands today, would get the interface and on the explicitly implemented on the base, so you have this new method available. There's no extension methods, no anything. Nothing's needed because you just override your virtual, right? Over on desktop CLR, the extension method exists. It looks the same, but there would need to be a registration.
No, there would be extension method. Extension method will be the API to get the columns. It's just the implementation of the extension method would be different depending on the platform.
Why would you need the extension at all if you just can cast the interface and use the method?
Because the problem is on full framework, you can't cast to the interface. Right? If you're on full framework and you want schema information, you can't just say, or I mean, you can say, you know, does the DB data reader that I got implement this interface? But the answer will always be no. So the only way you can get to the, you know, to the DB column collection is via this extension method, because the desktop implementation provides that via the old mechanism. And on .NET Core, the implementation of the extension method does the try cast and then calls that method instead. Does that make sense?
The extension method provides the portable surface.
Yeah.
It's the only surface that works in, you know, everywhere.
But aren't we going to be stuck around with it for all time?
Yep, you're then stuck with that thing forever.
Well, as I said, so I'm not sure about that. We can, I think, long term, we can transition to a world where there's this interface, potentially its members. I implement it not explicitly. I don't know. I think we can design it such that, or we should attempt to design it. I don't know if in this room, such that we can transition the world to just use directly the members of the interface. And then you don't have to import the package that has the extension method.
Well, let's say you're doing it like you're telling me. What's to stop me from casting it and using it?
Well, there's nothing. You just get worst case and null ref, right? Or an invalid cast exception.
Right. Well, I would just do as, and if I can use it, great. If not, I'd fall back to the extension method, right?
Well, the extension method would do the same thing. I would say even on desktop it would do the as and.
No, but when I was talking about the transition longer term we would have a public virtual method on data on the base class. Yeah. So you know, at some point, if you basically switched your portable library to some future generation where this virtual method now exists, you don't have to use the extension method and you don't have to do the downcast to the interface.
Yeah. So the whole point of this fancy design is to be a stopgap between. We have like this set of platforms today, which includes like .NET 4.6, and we really want to enable the functionality here.
Right.
So we add the extension method, and we have the funky call pattern. And if there's no, like, everything that I hear about this is that this isn't a risky feature to deliver to desktop. It's just going to take time.
It doesn't exist in 4.6 today, which is already shipped.
So there's nothing stopping us from putting the right design in, like, let's say this is generation 1.3 today. We have 1.5. This is associated with .NET 4.6.2 or 4.7, whatever it ends up being called, the next thing. There's nothing preventing us from putting the right design here. So this one has the virtuals. And we could do that now. The only downside of doing this is you basically create yourself a roadblock for adding API to desktop. Right. So if this was at all risky, then you wouldn't want to commit to it now. You'd want to hold that until you knew you could get it into desktop. Once you know you can get it into desktop, put it here. Then people, if they want to avoid using the extension method, if they want the better semantics, and they target this thing, right. And then their platforms are restricted. They have to have .NET 4.7. And then at some later point, when we don't care about this anymore, .NET 4.6, like if 4.7 or something later has full saturation, we might be able to eventually obsolete.
Oh, he's funny.
So that would be like super long term. But in the meantime, like we could even change the implementation so that it just like consolidate the implementation, reduce the code debt on these places up here.
But so now we're talking about, think of it from a consumer standpoint. You're talking about, okay, today I get schema table, then I have if-defs for this, then I have if-defs for the new version.
No if-defs. No if-defs. If you wanted to target old stuff,
you'd use the extension method. If you didn't care about old stuff and you wanted some cleaner code, then you could eventually target the new thing. The whole point is not to, like, we don't want to have if-defs. The reason why we're doing this work is to create a set of portable API that can work in a broader context.
Yeah, so another way to look at this is to say, our goal today is to create a portable story for getting schema information that will work on full framework as it is today without us either changing behavior or adding new APIs. The worst that can happen in this proposal is that we introduce types /APIs, methods, that would be duplicated in the future by us adding a proper virtual method to the base type. But it doesn't take away that the feature will still work the same way. So at that point, the only thing that you have is on the consumer side, you have multiple ways to get the same information, which, quite frankly, I mean, me as a purist, I don't like it, but if you look at full framework, there's plenty of places, even in ADO.NET, that have the same characteristic. There's 5 ways to do the same thing. Oh, yeah. That will be the only one that we would say, you know what, it's not as clean as we can get it, but it has a nice characteristic in the sense that it's portable today. We can probably even make it work on full framework 4.5 if we really cared, because we don't actually require any new APIs. And on .NET Core, we have a somewhat clean story. And long term, there's an even better story because we just add a virtual to the base.
Yeah, I don't think I disagree. I'm just thinking through all the existing providers. I guess there's going to be no issue because we're just calling it schema-table underneath, right? The full schema, you're talking about the implementation of this method on core is strictly that. There's no changing it, enhancing it, and that will never change on core. But then when you go to the next version of core and there's an extension method, then what? It tries to cast, and if fails, goes to get schema table? Because later when they do implement the interface, what happens?
Well, I would say that if you introduce a new way, the provider has to opt in by implementing the interface or overriding the virtual. If they don't do that, our mechanism, either the base virtual or the extension method, depending on what we do, will just call through all the APIs. So I would say if they opt in to implement the new interface, then that becomes whatever they do in the implementation. If they introduce a behavior difference where GetSchemaTable does one thing and then the new API does something else, well then it's their problem, I would say.
Okay, so you're saying what you're depending on is once they implement the interface, the extension method would no longer be possible to be called, unless you explicitly called it.
Well, you can still call the extension method, but the behavior of the extension method will be fixed, right? The behavior will be, if you implement the interface, I call it. If you don't implement the interface, I just call GetSchemaTable. So if an existing provider never changes, we keep calling DataTable forever. If they update by implementing the interface or overriding the virtual, well, then we call the new API, and you get whatever behavior they put there.
Okay,
so,
but the interface is going to have the exact same method name as the virtual we'd introduced, right?
Well, the way we would probably do it, we would say the base type would so in V1, what we could say is we could say the provider can implement interface directly. Let's say the provider does that.
Okay.
So then you get behavior of X, right? Now later on, we introduce the virtual in the base, and also implement the interface by dispatching to the same virtual. So what now happens is an existing provider who doesn't override the virtual, well, they override the interface still, right? Because they also implement the interface. So if you call through the interface, you will get the old, the more specific version, which is on the more derived type. You see what I'm saying?
Yeah, I totally understand that. My question is, are these going to match?
Override the virtual and implement the interface. Well, then it's honestly at that point it's a bit confusing on their side. Potentially they could have two different implementations, but the same way to do it would be getting rid of the interface and just overriding the virtual at that point.
No, I'm saying literally the method names. Is everything going to match? Because otherwise I have to if-def it out forever. That's what I'm asking. Are the method names for the extension going to match the virtuals? Because that needs to be the case if we are avoiding that.
If we do our job well, I would just say the interface, like the extension methods would have the same signature as the interface method. Okay. So that they essentially just hide.
All right, that's what I would think. I'm just making sure.
Anybody else? I mean, it seems to me the saner model.
The code will need recompilation, though. I mean,
well, strictly speaking, I mean, you get a different behavior in the sense instead of calling the interface directly, you call through the extension method, but the extension method would just call the interface anyway, so you get the same behavior.
Yeah. No, what I'm saying is that your code right now knows that, hey, I've got to call the extension, the DLLs, but then those DLLs have to be regenerated if the extension method is removed, right?
Sure. Yeah. No. That's
all I'm saying is I'm pointing out that that could be the only concern if we keep the API names also same.
So let's step back for a second. So if we talk about removing an API like the extension method, what that really just means is that like we can never remove anything realistically, right? It's always there. All it means by removing stuff is we can factor it into a different NuGet package that becomes an optional component. You can still use it. It's still there, but you don't have to use it because we have a better API implemented in the core. So depending on where we put the extension method, it just means that people will stop referencing that guy. And then we may be even deprecating that, which I don't know whether it's worth it because it's literally the same API, right? Like why would you go out of your way to make it people suffer?
Yeah, it's just an interface. My main concern is like if I compile Dapper, for example, for a year or 2 years from now for 4 different generations, if you don't match, forget recompiling, I have to if-def.
Yep.
Right? Regardless of if you do. So yeah, I'd much prefer them to match as well.
Yeah, so I think what will happen is if you write code today that calls this method, your source code will be identical whether you call through the extension or whether you call the interface directly. Now that's the consuming side. Now the producing side, if you're implementing a provider, well your code will change depending on which mechanism you want to use. Because you either implement the interface or you override the base, right? And both of them have different syntaxes. So, but I mean, we will make it so that you can continue to use the interface method forever if you wanted to. It's just that we also give it a virtual to make it a bit easier for new people to, understand their own provider essentially.
Yep.
Does that make sense? Cool. So that means what we would need today is we would need to say we need an interface, we would need a method, and we would need to decide where to put both of them.
And what the names of the methods are, and also if somebody could play with the future, like how we would actually, transition to what we just talked about, where the APIs are actually on the stack.
I think for now I would assume that the interface and the extensions would both go into system data common unless we decide something else.
That does make it harder to factor out.
It makes it harder to the question is it worth it? Because we're talking about one type of one method.
Yes.
Introducing a new package for that seems excessive.
Yeah, I agree.
Yeah, there may be some follow-up methods that aren't related to this discussion. For example, like bulk insert and things, take data set, and there's going to be some demand for that from other parts of the community as well. That's totally somewhat separate discussion, but it's the same lineage of stuff involved.
But that's basically the scenarios for using data table, correct?
Data table or a data set even. Now I know data set's not coming. Please don't port that. I'll off myself. Don't. It's terrible. But there is a need there, right? Implementing a data reader is not trivial, and that's how you would currently do bulk inserting, for the most part, right?
So one thing, given that we have, like, is there anything more to this proposal? Because otherwise I would use the remaining time to just have a quick chat on data table and data set, if nobody minds that. Is there anything else you want to talk about for this proposal?
And what would be the next steps? Would there be another review, or?
So what I would do is I would just ask you to essentially design the interface, design the method, send a review on the API shape. Just copy and paste, like similar to this essentially.
Seems like it's pretty much already here, isn't it? Just change
that one. And then just outline essentially, like in bullet points, what happens in vNext. Like what happens if we actually add a virtual to data reader? How would the existing code transition, both on the consuming side as well as on the production side? And then the other scenario that I think we all agree that it works, but it may be worthwhile outlining is, how does portable code that compiles against the common subset work on full framework and .NET Core and getting the same sort of information?
Okay. So I have a related question to this. I mean, this can happen for anything, right? And we had this long discussion for one API on DB data reader and data tables. Since they're not there, there are a bunch of other APIs which may need replacement. Let's say we had another API on DB connection for which I have an issue, but that's far more complex than doing this one. So do we follow a similar path forward for these APIs in case we come up with concrete for other APIs? For example, we came up with a read-only collection of DB column instead of data table for this particular API. But this can happen for many other. This may happen for other APIs. So what is the right path going forward? I mean, something similar, or is it to be handled on case-by-case basis?
So my general, I think, goal would be to say, so we have existing APIs that we may be unhappy with for various reasons. I think what we have done on our side, if you look at holistically what we did across the BCL and other places, is during Windows 8, when we designed the API subset we gave to store developers, this was the precursor of .NET Core. We heavily optimized for cleanliness. So we removed APIs we felt were just not designed well. In some cases, we provide alternatives. In some ways, we didn't. And so a good example would be Reflection, where we didn't do that. And now we're talking about adding a bunch of functionality back, because turns out adding alternatives in many cases is actually very expensive. So I think in general, like if you are unhappy with the design X and say, I want to kill this design, I think whoever owns this technology, the onus is on that team to say what the replacement is.
Okay.
Like sometimes the answer is there is no replacement because the technology is just the wrong way of doing things, which the runtime team and the framework teams have done as well. Like for example, we said we want to kill app domains, we want to kill transparent remoting, we want to kill binary serialization, and for some of those things, there aren't one-to-one replacements. We just said we know it's too expensive at the runtime layer to support that. Sandboxing, the security is completely gone. There's no replacement because it's just no longer a goal that we want to pursue. For cases where you say, oh, the scenario is still there, like schema information, just down like data table, well then, you have to outline how you would get the same information with a new API. Now, once you have that design, the goal that we have is to say, okay, what's your portability story? If I want to target full framework and .NET Core, my default answer would be you have to make it so that you can do that. Like if it's okay to say, well, in some cases we may be forced to add APIs to full framework, that would be unfortunate. But also my default stance would be if you can design it in such a way that you can, just have a standalone library that you can add to your .NET Core, to your .NET Framework installation, and now you can write portable code between the two. That would be fabulous.
Okay.
And so that's generally the approach we take. Now, in some cases, it would be, maybe in such a way that you would end up with a very complicated design where it's maybe not worth doing. Right? In some other cases, it may be, a good example on our side is we talk about a new API to represent buffers. If you look at some APIs you have in the framework that deals with byte arrays, there can be a ripple effect where add a bunch of overloads all across the board. So you want to think about what happens if you introduce a new de facto type to pass around data. What does it mean for the ecosystem? Like how much complexity do we push on our consumers? And in some cases you have to, maybe it's worth it. Some cases you may say, you know what, the API that we have is what is nice, but is that offsetting the cost of forcing a new type across the entire ecosystem?
But you see, this I see it as a bit of a balancing act.
Yeah.
That's why I kind of didn't like the original proposal of, with registration, because to me it crossed the threshold of, geez, we are like butchering, we are butchering the APIs to get portability and accomplish this. This one is not what we would design if we had complete flexibility, but it's pretty close. It's like, for consumers it will be, they would have to dig and actually understand what's going on to see that it's not the ideal API that we would like to have. So to me that kind of strikes a good balance between, having APIs that are nice and provide portability and don't butcher the new platform for version.
Yeah, I like this API. I mean, it's better than what I proposed, but there are certain constraints that. But I see both your points. And
but of course, let's say we couldn't come up with a solution that we feel like it's acceptable. I think we should just basically say in some cases, too bad, it's a new generation. You only have it in the new generation. For now, you're gonna only have it in .NET Core, let's say, and then in 5 years when the adoption catches up, as Eric was saying, then you have it in a portable surface.
And in some cases, let me give you a concrete other example where we have done something fairly drastic. Is if you look at reflection, reflection object model was at some point extended to allow essentially other people to read metadata outside of the runtime environment. So think of compilers, right? The compiler's type system could be represented by the reflection object model. Right? And in VS, there's certain implementations that do exactly that. No, when we shipped Roslyn, which is the new managed compiler, they had a different metadata reader, very low level, very low overhead. So now we have a new thing called system.reflection.metadata, which, except for the namespace, doesn't share any APIs really with reflection. It's a completely new set. But this API set is heavily optimized to say it is super lightweight, it doesn't do much of any allocations really, and it's designed to read arbitrary metadata. And we felt like, we could probably change reflection, but as Christoph said, at that point you would butcher reflection to a point where like, okay, now we have a single uniform API, but are the compromises that we have to take in the design really worth it? Because do you really get the compiler APIs out of it that you really want to get? And do you get the performance that you want to get out of it? And if the answer is no for too many of those, it's like, unfortunately the API or the technologies that we have, it would be nice to unify that with a new set of requirements, but it may be better to literally say, this technology is not for this particular scenario, so we have an alternative technology that is way better for that scenario. But I mean, in the framework, I think, as Christoph said, there's a balancing act between how many concepts do you expose and how specific are those concepts mapping to what you want to do. And so at some point, you cross the threshold, and then the burden is, I think, on you to prove that there is this threshold. Because in some cases, quite frankly, it's just intellectual laziness on the API designer to say, oh, I don't want to think about how I retrofit this existing thing with this thing over here. But then you just push the burden on the customer to do the same exercise. And I think what we are saying is, no, the burden is on you. If you tell us you can't do this for the 5 reasons, it doesn't mean that we tell you no. It just means you have to outline those 5 reasons, and then we can have the conversation about that.
Fair enough. Okay.
How about let's say we're gonna introduce new types, right? In the context, because it's faster to release and things like that. And then we noticed that this class is good, and then we decided that we're gonna port it to the .NET frameworks. Once we port it to the .NET frameworks, then we get this similar issue and we want to iterate this new API, right?
So that's another interesting observation, is that if you look at .NET Core, what I said earlier about portability for the customer is applicable to us as well. So we have libraries like our immutable collection library, which is compiled in such a way you can use it on desktop. So a .NET Framework developer can use that library just fine. So in that sense, it's available to desktop, it just doesn't ship in box, which means we can iterate it as fast as we want. Now, the only problem that you have is that means in the .NET framework, no API can take a dependency on this immutable collection APIs because that would require this thing to go inbox as well. And so, in general, that means if you want to maintain your agility that an out-of-band library has, that means the inbox components can take a hard dependency on that. And for some APIs and for some patterns that works. For things like ADO.NET, where you essentially have an object model and you're basically providing an inheritance hierarchy that you expect other people to derive from, it kind of ties your hands, because as soon as you make this a concept of the inheritance hierarchy, you have to add it inbox. Like, you can no longer have it out of box. And so there's this this balance. I mean, if we can help it, we always try to design new libraries in such a way that we never have to physically add them to desktop. Like our metadata reader is a great example. I mean, BS is using it, Roslyn is using it when it runs on full framework. Roslyn itself is essentially a ginormous set of portable libraries, and neither of them ships in full framework. Okay. Yeah.
There's a lot of if-defs for that one, by the way.
There is, but we worked very hard with them to have fewer.
It'd be nice if that thing shipped with extension methods instead. Well, they are extension methods, but they're not extension methods in core. So every library we have, literally every single one of them, has extension methods to map to the one or call your extension method.
Yep.
It's very weird, because that is the one set of libraries that we have, like, basically a copy-paste class that hopefully gets inlined everywhere. Now, granted, we do a lot more IL than a lot of libs do, or a lot more reflection in IL.
Any more questions on that in general? Otherwise, I would like to talk about DataTable, because Nick, you said you tried to port DataTable, right?
Yeah, I have it on my laptop. It's about 20 errors away from compiling. Man, there's a lot of crap in there. Holy crap. I went to .NET 4.6, the reference source latest, and just went to porting it in. And there is, I don't know if you've looked at it, there's an incredible amount of business logic and transaction control and all inside of it, right? You can treat it like a miniature database in memory, dataset.
Yep.
And there's all the features of a database, or a lot of them.
So, like, my question is, like, so if you look at what we have done in .NET Core as well, is like we obviously tried to create an awesome platform with ideally no legacy, no deprecated, and obviously the APIs, just awesome APIs, right? But we've also added APIs that we consider legacy or done in some cases. But we could isolate them nicely, so there's not necessarily a reason not to have them. So a good example for that would be non-generic collections.
Right.
And so what we have done is we basically created a NuGet package that basically just contains array list and hash table and all of that. And you can reference them if you want to, but we try really hard to make sure that no new components take a dependency on those, because they're considered legacy, for porting essentially only. So the way I said it on the GitHub thread is that's the same way I kind of see DataTable and DataSet. So to me, I think everybody agrees DataSet is a terrible API. DataTable, I don't know, a generic DataTable doesn't seem bad to me, because it's, as you said, it's sometimes useful. Now, it has a bunch of overhead. It's a pretty heavyweight thing, but if you need it, it is a damn useful thing to have. Now, how do we think about having that thing basically as a separate NuGet package, let's say system.data.table, whatever, right? And have it as a standalone thing. And given that you just ported it, you're probably the best person to talk about how much work that was, or how much work did you predict it to be.
2-3 years.
Great.
4 hours.
One of the reasons it's so, and now ported it disconnecting dataset while porting it, right? Because that was the exercise for the purposes of this kind of API, right? If you bring over the dataset as well, there's a whole truckload of dependency in there. It's a massive nest. There's probably, top of my head, 30, 40 classes you're going to have to bring in for dataset, because you have your columns, you have your rows, you have your foreign keys, you have your associations between data tables, you've got all the business logic, and you're entering and exiting specialized transactions. It's not even using some of the other transaction APIs, which also aren't in .NET Core. We'd love to see those, by the way.
Yeah, that's a separate discussion I already have an item for, but that's owned by somebody else again. So,
okay, yeah, let me know how that turns out, because we're having to yank that out of our exception handler and stuff. so all of that's built in, and it's not system.transactions necessarily, right? It's an internal transaction management because it's, it's an in-memory database effectively, right? But I think a lot of people are using it. I think, and maybe my view's skewed here, that a lot of people using this are never going to move off full CLR. It's just not going to happen. Now I know like Franz has different people that use the library that and may have better examples than I do, but it's just massive. Like you're building a humongous app to either collect all your data in memory, sort it all out, and then do a bulk insert in the database, or you're just running the database in memory effectively with the data set, right? These are like hardcore legacy type of apps, and I just don't ever see them moving, honestly. Like they're using so much of the old world. I don't think they'll ever move to core. I think they'll rewrite the app or move to a new platform or something.
I agree.
But that's my experience. I could totally have been missing 95% of it. That they'd move fine. I think it's movable. I think you could do it. I don't think we should.
I have a very similar opinion on that. I think that most of the data table is kind of useless today, but I would really like to see an official way to have kind of a data table, but a simpler one, kind of a data reader or something that we can represent a tabular data in memory. It doesn't have to have transactions, selects, indexes, or anything like that, but from a very user perspective here, I was working exporting Excel files, and I was looking at that, and there is no simple way to do that on .NET Core, because there is no way to represent that data. We need to build those structures to simply represent a table of information. Right? Yeah. So I would like to see an official way to do that in Core, that it's not tied to the old data table, it's not tied to that structure, but it's not considered legacy. It's something that is ready for users to use, but a much simpler one.
Yeah, I think bulk insert is one of the big use cases there, or at least in my experience. Okay, for example, at Stack Exchange, we have an app that we can't port to Core, which is called the Traffic Processing Service. Every HTTP hit we get a syslog message from a proxy. It hits a service on the SQL server, just happens to be running a very powerful box, and it inserts them into SQL. Batches, loads, it's a data flow, like any other type of data flow. But you're using bulk insert, right? Obviously, you're doing cluster column store in this case, so 100K at a time, and you're using dataset or you're using data table today. There's no great replacement for that. You're basically newing up a data reader and implementing all of data reader to do it, and that's not a great API. So there's definitely a hole there in terms of just representing tabular data, and then in some cases doing something with it. And usually just look at any of the methods removed from DB data reader. Those were the common touch points, right? Or DB. Not DB inserter. Command. Hang on, I gotta find the method. I pull up this code.
So I mean, one question I would have is like, if we say, there's a need for, let's say, a simpler data table, or a simple, a simpler concept that basically holds onto tabular data or whatever that is. Do we think that would be a completely separate API, or do we think there is a subset of data table that would be in what we consider the good case? Meaning, if we could remove APIs in data table, which we can essentially by saying we port a subset of data table to .NET Core, would that be something that we think would be a good API, or do we think, oh god, this thing would be look completely differently, would have a completely different storage mechanism? The API would look nothing like data table that we have today.
But is the ask about tabular data, or it's about bulk inserts? It's basically bulk inserts, the thing that is missing?
It's both. Sometimes you just have need for in-memory tabular data, right? Which isn't really that different from a list of T for most of my use cases, but I totally see people that actually use a data table for more of that, right?
Well, it's more like a list of object array, right? Because I mean, if you look, for example, let's say you want to have a bunch of data that is dynamic, you just want to, for example, have it bind to a data grid because you don't care, it's just a visualization. What mechanism would you have? I mean, list of object array is kind of like that, right? Except that it's not really the right abstraction because you can't ask like, what's the type of the second column, right?
So the scenario is data binding. That's why people.
Well, I would say it's like you have data that you want to store either just as an in-memory way, or you want to store it in order to do a bulk insert. But I mean, the scenarios are very similar, right?
Anyway, I was kind of asking, because I think it would be good to understand what scenarios are missing, not what APIs are missing.
Well, I think it's a little both, right? Because when you have it in memory, you want to represent your foreign key. So if, for example, I add a row and then another row has a parent ID, I want to make sure that's valid before I toss it in the database, right? So I'd want to bulk insert in order and that kind of stuff. So it's a little mix of mixed use cases there. Really, they overlap a lot.
Yeah, for the cases I work with, at least for the ones I care, I'm not very worried about the foreign keys stuff. I'm just worried about having a simple way to store data in a tabular array. For example, exporting to Excel, importing a CSV file. I want to reference a column and a row, and I want to get data from there and store data there. And I don't care much about the transaction side or for checking if the data type is right. So it could be pretty much like a list of object array. But it needs to be in a way that I can access column, row information based on an index.
So you don't care about the constraints?
Well, I think this is important for some people, but thinking about a simpler API, I think that it would be great to have a simple object to do the basics. Okay. And from there, we see what people are really interested in, because I think that if you start to build from the data table, you'll get this huge thing that probably a lot of people won't want. So I'm more looking into a simpler thing that we have the basics right now.
Okay. Yeah, like I think once we try to talk about scenarios, I think it's worthwhile to just mirror what data table and data set have, and whether we can get there by just trimming rather than starting from scratch. Because I mean, it may be easier to trim down to something that is kind of like close to what we want versus the other way around.
Yeah, but that would need to be a new API, right?
Well, I mean, like, as I said, like let's say, for instance, we would say, all this transaction logic is super complicated and terrible and not that useful. So you could imagine a version of data table and data set that just don't have that ability. So, like in that sense, you can think of it as a, similar to system data common, right? Originally didn't exist in core. So we took basically all of ADO.NET and trimmed down to something that we felt was, the core provider model and exposed that to core. In the same way, you can say, data table, data set, maybe there's something smaller in the middle that kind of does what you're describing, but doesn't have all the negative complexities that we don't like. So that's the part we don't port to core. But then again, you have a common subset between the two, and you can actually write code again that works on both sides. The concept is, for the things that are the same, is literally the same. And maybe there's, moving forward, some new APIs that do some things that data table doesn't do today.
It's just whenever we do it, there's a fork in the road, and it makes it harder to add new APIs in the future, because they may conflict chronologically with the ones that already existed in the past.
Correct. That's the typical trade-off of having a non-inbox component.
Yeah.
But that's what I'm saying. I mean, another option could be to say you could just leave data table, data set alone. I mean, if they're literally just in memory, right? It just seems like a porting exercise. It's there. It's exactly the same way as it is in desktop. If you want to use existing code, you can, but maybe there's something better moving forward, and then move your code to that one. Or we just say, it's so hard to port data table, data set. It's not really worth it. I mean, there's various ways we could go about it.
Yeah, I think I see that point. I just think that if you start to trim down data table, you will end up just creating a new one, because I don't know, at least looking at the source code of data table, there is not much there that we can use today. For example, selects, indexes, finds, and anything else could be done with link, probably with dynamic. I don't know if it's possible to use dynamic with that kind of structure with link. But looking at the data table, there is not much there that we need. So trimming down that, I don't know, looks like a very huge exercise on removing 99% of the thing.
Well, Emo was, I think, talking more about trimming the APIs, not the implementation. You could imagine you just create a subset of APIs and then you re-implement them from scratch.
Okay, so it would be like data column and data row?
Basically,
keeping
I mean,
that.
that's my question. Like how far, how much stuff can be salvaged? Like if the answer is the only thing we can actually use is the concepts, then that to me sounds like more like a rewrite. If it's like, the concepts are not quite that bad, the implementation is maybe terrible, but the APIs are somewhat decent, except for a few errors that we think are terrible, then maybe cutting down what we have and churning the result, maybe not a bad approach. As Christoph said, the problem is as soon as you do that, you're signing up for maintaining compat between full framework and .NET Core in some meaningful way, right? So you can obviously add new APIs. It just means as soon as you do that, unless you add them to a full framework, you lose that compat part, right? So it's the same discussion we had on the provider model earlier. That's what I'm saying. I mean, there's a trade-off between the two. As I said, like another alternative view is we just leave them alone. We just don't port them. Another option is we leave them alone, but we do port them, and they become both legacy components. And we add a new API that is completely self-contained, can be used on full framework and on .NET Core, and we can rev it as fast as we can. And so that's basically the three options that I see. And I was just curious, like what you guys' readers, what data table data set represent to you and what you would like to see.
I think if you trim them down, the fall-off graph of usability is going to be pretty steep. Because the people who are using those specific things are like your commits and everything like that. I mean, it depends how much you trim is going to reduce some percentage of users who the use case is covered, right? I think you honestly have to go back to the community to get a really good view. But my feel would be when you start trimming, and you're going to want to trim a lot. Because in my ported version right here, I've still got 100 plus methods. I mean, there's data table goes to XML and all that stuff. I assume you'd leave that out, right? But that's one of the heavily used pieces by a lot of people because they're rendering it, either reading it from XML or writing to XML, right? A lot of these legacy systems. So if that goes away, what percentage of users does that kill off, right? It's like any other feature discussion.
Yeah, I agree. There's a danger of like if you trim too much, you just create an illusion of continuity. Yeah. And then people try to use the API, they find out they don't have so many features, and then it's just sends their own message.
Yeah. To comments on, I mean, if for the compat issue, right? I mean, if you create new type, and at the end of the day, if you port it to .NET Framework, then there is a compat issue as well. So once you
So say it again. If you create a new type.
So you're saying that if you create a subset, string subset of data tables, the bad things because we need to manage the compat, right?
Yep.
So if we don't port it and consider that legacy, we create new stuff in .NET Core, but once we port it to .NET Framework, then it becomes compat issue.
Well, that goes back to like how does porting look like, right? The way I would do that is, let's say we would create a new data table abstraction, right? They call it, I don't know, awesome table, let's say, right? So we now have awesome table on .NET Core. It can be a completely self-contained MSI-only assembly, which you can use as is on full framework, which means we don't port it to the framework. It's just a NuGet package that you can reference for full framework apps as well. And so it's immediately available on both sides. And if we add new features, well, it's immediately updated on both sides, right? So I mean, that would be, so in that sense, we don't, like if we can help it, as earlier, we don't port it to full framework as in be adding it to the redist.
There is one issue with having data table in a separate NuGet file is that most people that use data tables will depend also on data adapter, and you will need to port that as well because people that are using that heavily need to use data adapter for inserts and selects.
I'm not sure how common that is. That may be anecdotal as well, which may be everything I've said about.
Yeah,
like,
I'm thinking about people that care about the legacy stuff of data table data set. I don't know, but I see that when I retrieve a data table from the server, I usually go directly with data adapter. It does all the hard work to fill data tables.
Well, I mean, to be fair, like, I mean, if we were to do that, I mean, you still have options, right? Because the nice thing is these APIs are somewhat nicely layered in the sense you could imagine a world where, you know, ADO.NET, like the core layer, is in one set of packages. Then there is the data table, self-contained on the other side. And then there is a set of packages in between, which depend on both sides. And, you know, so you would basically have, like, if you're using a SQL client, you would use the SQL core packages, you would use data table, and you use the SQL-specific data, adapter for data table. So you could layer them as 3 different sets that you can reference. And then it's pay for play, right? If you don't use table adapters, great, you don't pay for them. If you use them, well, then you use them, but they don't have to coincide in the same packages.
So I think there's multiple levers of API here, right? One is what are people using, and I think that's almost irrelevant because those people will never move to core. Those applications will probably never move, a very high percentage of them, right? Then you have the libraries that depend on data table, data set. What do they use? I think that's your only really important set that needs to come. And that that's probably look at the current open source APIs and see what they're touching. And maybe it's a very small subset, maybe it's not. And that's type forwardable, and maybe that's all we ever port, and they don't get touched again.
Yeah, it seems to me that most libraries use data table as a transfer object. It's usually just to transfer data between APIs. It's just return data to the user so they can do whatever they want with the data grid. But it's not using those methods with indexes and finds and all that stuff.
Yeah, if they're not using XML, they're not using record locators, they're not using the data set ties, then that's a slam dunk win to bring over, I think. That would unblock a lot of people.
That's a point that I think about a lot, because if you care about data table, like ASP.NET or .NET Core is like a huge change. Data table is the least of your problems. You don't have Windows Forms, you don't have WPF or whatever you use. You don't have ASP.NET with data grids to use data tables. So why are you caring about data tables if you don't have anything else to use that with?
So let me answer this, because I think the split you made earlier, Nick, I think is a valuable thing, which is you say on the one side you have data table, or like the library consumer, but on the other side you have the app. From looking at my own apps and looking at what some of our customers are doing, like there's just a bunch of gray area in between, right? I mean, if you look at larger apps today, let's take TurboTax as an example, right? TurboTax is a set of apps. You can think of it as a singular app, but I mean, they have multiple experiences, right? They have an iPhone experience, they have a desktop experience, they have a website experience. So they obviously, their own app is componentized into a bunch of libraries, right, that they use from various devices.
Right.
The benefit that .NET Core adds, or I should say .NET in general adds, is since V1, they tried to say you have one framework that you can basically use for your entire app ecosystem, whether you write a website or a Windows Forms app or a console app. It's the same set of APIs you can use anywhere. Now, the nice thing with .NET Core is, we can even do this even more aggressively than we could with full framework. But that means I don't think it's very easy to say there's a cutoff line where you can say, clearly that's just library, and clearly that's just apps. I think there's this transition piece in between where you have libraries that are part of your app or your families of apps, and the more stuff you can use in there, the better you're off. So it's not that, because there's no Windows Forms, so there's no data binding, so you don't need data table. I think if you walk that chain, you might as well just say .NET Core could be a completely different platform with a completely different set of APIs. But clearly that's not true, right? There's this continuum of like, how portable can I be? How much code can I reuse? How many if-defs do I need to write? And like obviously there's a complexity threshold for us and cost importing, but there's also the other side of it. Just if you artificially not give you APIs, that's the death by 1,000 paper cut problem that many of our customers complain about when they move to Core. So I don't know. Like, to me, it's a bit of a I don't think there's an obvious answer, but the data table is clearly just a UI concept, or clearly just an enterprise concept. I think there's a bunch of cases you could make where, I'm just writing my data access layer, and ideally I want to reuse this for my website and my Windows Forms app. But my website now moves to .NET Core because I want to run on Linux. My Windows Forms apps are not going anywhere, but I would like to use the same library on both sides. I mean, that seems like a scenario that wouldn't be completely insane.
Well, as long as the library is what I'm talking about, right? So as long as they're covered, you're good on both sides.
Yeah, what I'm trying to say is, if you say library, I'm thinking of like JSON.NET, which is, I have a self-contained thing. I don't know anything about my apps, and I'm saying there's this other area where it's your business logic that is specific to your app, but it's still a library because you use it between different devices, for instance.
I hope James doesn't add data table.
No, I don't.
Yeah, I get what you're saying. I think so. The way we've done this in the past of seeing what's needed, what's not needed on some APIs. I don't know if you guys have actually taken the approach of actually searching GitHub. And there's a lot of enterprise you're not going to view, but usually when we look at it, percentage-wise, what people are doing is roughly the same percentage use cases of whether it's open source or not, right? So when we're searching for, as somebody using this method, can we move it? Can we change it? Can we deprecate it? Obviously, in a breaking release, we're looking at GitHub. We're actually searching code, and we're seeing where this is called. And
You're
I think
talking about your own APIs, whether you can deprecate them.
yeah, so like on DataTable, say write XML schema, you actually look through GitHub and compare it to any of the methods, right? You can actually kind of empirical and even script-wise evaluate an API and see what are the hot spots and what are the really cold spots.
But there's a problem there, because if it's there, people are using it. It doesn't mean that people want to use there or it's that their best option. It's just because it's there. So if you just search for code, you may end up getting a lot of code that is used, but it's not really relevant. People could change that.
Well, that's fine, as long as you're providing another way, right? But in general, you're going to know your hot spots and cold spots from that. Like, are 2 people using it or 1 million people using it, right? Obviously, that because you're not either you're porting all of it for 100%, or you're porting, say, 90% gets us 95% of the users, or 20% gets us 95% of the users, right? It's all about your fall-off graph, and that's all we're trying to determine with any of these, right?
Yeah. No, I mean, I think you're completely right. I mean, that's what we do on our side as well. Like, we have various data sources that we index to find API usage. GitHub is one that we haven't completely in mind yet, but there is a bunch of people working on that as well, so we can get that data as well. The thing is, though, the challenge that we face is that if you look at specifically things like ADO.NET that are more, enterprise heavy, the problem is data sources themselves can give you a very skewed view of reality, right? For instance, if you look at Store, well, Store doesn't really have a concept of a database that would make a lot of sense to most people. You may have a local cache of a SQL CE or SQLite database, but it's not your typical 2-tier enterprise apps, right? So the usage you would get from Store, how databases are being used, will be drastically different from how, let's say, an ASP.NET website would use a database, right? And so the problem is data sources themselves and like the use cases they are after, one particular SKU. GitHub, on the other hand, that's open source libraries. That's not the enterprise app either, so that you get a different SKU. We try to get as many of our data sources and try to get a quantitative view of the world.
Yeah, you guys have a much better view of the enterprise, obviously. The ones I think that are really going to make a difference on DataTable in terms of porting effort are going to be, is anyone using transactional stuff in it, right? Like .accept changes and everything that entails, and like bids and scopes, and are they using the XML pieces? Those two are a humongous chunk of DataTable. And if that doesn't come over, then yeah, it's probably worth porting. Otherwise, it's a mess. It's a here, I actually have the solution open for my port here. Data error, data column change collections. Like there's a whole list of events and everything else in there, and I don't know how much that's used.
Yeah, that makes sense.
It's a deep rabbit hole, though. Right there.
Yeah, it seems to me that if DataTable is ported, it should not be trimmed down for how can I say? It shouldn't be trimmed down. It should be kept as it is. It shouldn't be updated anymore. It should be kept as legacy as it is. Because the transaction side it's not using system.transactions, right? It's using the DB transaction and all the things that we have in ASP.NET in .NET Core, right?
It's using bids and scopes inside of DataTable.
It is scopes. Okay. Yeah, but it seems that from the API level, it's not exposing them.
All right, guys, we need to wrap up because we lose the room.
Okay.
Thanks for joining the call. It was super helpful. I will send out notes later as a PR to the notes repo, and then you can comment to make sure that I captured it accurately.
Okay.
Sounds good?
Sounds good.
Okay.
Thanks, guys.
Awesome. Thank you, everyone.